Hi guys, today in this video we'll solve this problem using Thevenin's theorem. So Thevenin is a name of a scientist who invented this theorem. And here the question is like this: find the current flowing from the 5 ohm of the circuit given below. Okay, here is the 5 ohm. Here is the 5 ohm circuit. Now we'll point this. This is the 5 ohm circuit, and we will say we can solve this problem in 5 simple steps, using 5 simple steps only. So first step is we have to remove the load resistance. Now what is the load resistance? The load resistance is the resistance which is given in our question. Okay, so this is our load resistance. So firstly we will remove this. Now this will be an open circuit. Okay, this is our step number 1, and we will write that our load resistance RL is equals to 8 ohm. This is 5 ohm. This is 5 ohm. We'll write this here. Now in the next step we have to say that how much current is flowing in this circuit. So let current is I current is flowing from here. Now if I current is flowing from here, then this will come in this way and this will come down, because here the circuit is open, so the current will not go in this way. So this will go here, and then it will go here, and this will come again here. So this will create a small mesh. Now we will have to find how much current is flowing in this mesh. So we can find it in a simple way. See, here the current is flowing in this way, so this is minus 12I. We will calculate it like this. Okay, the clockwise. As we are calculating this in clockwise, so we will write minus, and it's up to your choice. If you want to calculate it anti-clockwise, then you will have to plus. Then you have to plus it. Okay, so the first step is minus 12I, then minus 4I, then plus 48. This is equals to 0. Why plus 48? Because the voltage is coming from lower side from a higher side. It is jumping from here to here. This is the lower side, and this is the larger sign is the higher side. So as this is jumping from here to here, so we will do like this. Now, or minus 16I equals to 48 minus 48, or I equals to 3. So the current is flowing from here equals to 3 ampere. Okay, this is our step number 2. Now I'll remove this from here. 48 volt. Now in step number 3 we have to find VTH. Now what is our VTH? VTH is the Thevenin's voltage. To find VTH, now we have to create a circuit here, and which is like this. This is our VTH. Now how to calculate VTH? We can calculate VTH by taking a mesh. Okay, so when we are taking a mesh, we have to take the mesh like this way, that one of the mesh is covering VTH. Now here is 2 mesh, 1, 2, and the whole is another mesh. There are 3 meshes. So for easy calculation, I am taking this mesh. Okay, and we are taking this in clockwise. Previously we showed you that the current is flowing from here to here, and this is coming here because this circuit is open. We will do this time also in the same way. The current will flow from here to here. Now the equation will be like this. Here there is no current, so resistance will be as it is there. Nothing will change. Now this is minus VTH. This is minus VTH. Now this will come from here, and now you can see that I is flowing from here. I is coming down, and we are coming from this side to this side. Okay, the current is flowing down, and we are going upside. So we will write this as plus 4I. This is equals to 0. Okay, So minus VTH equals to minus 4I. We know that the value of I is 3. So minus VTH equals to minus 12. So VTH equals to 12. Okay. Now we found the value of VTH. Now what is our next thing? The next step. Now we'll write it here. The value of VTH. VTH equals to 12 volt. Now our next step. Now our next step is to find the value of RTH. RTH is the Thevenin's resistance. Now how we can find the RTH? I am removing the circuit from here. Hope you all draw the circuit. Now here RL equals to 5 ohm. VTH equals to 12 volt. Now how we can find the RTH? Firstly, you have to know that if there is a single voltage with no plus or minus resistance, then we will have to short it. We will have to short circuit the voltage. So, and if there is any I, that means current flowing, then we have to open that circuit. Now here is no current flowing in this circuit, so we will short it like this. Here there was a 48 voltage. Now we are going to short this. Now this is our circuit. So like this. This is B and this is A. I hope this one was 8 ohm. This one is 12 ohm and this one was 4 ohm. Now we have to find the RTH. How we can find the RTH? Here you can see that this one 12 and this one is 4 and they both are in parallel. Let the equivalent resistance is R1. So sorry. Let the equivalent resistance is R1. So R1 equals to 12 into 4 upon 12 plus 4 ohm, because they are in parallel. So this is equals to around 3 ohm. So if we reduce this circuit, this will become like this. So now our R1 is 3 ohm. If we reduce this circuit, this will become like this. This is our 3 ohm. This is 8 ohm. Open, open. Now here 8 ohm and 3 ohm both are in series. So now our RTH will be 3 plus 8 ohm, which is 11 ohm. So now we found our RTH. RTH equals to 11 ohm. Now we are getting an equivalent circuit of our first given circuit. So our first given circuit was like this. Our first given circuit was like this. This was 48, this was 12 ohm, 4 ohm and 8 ohm. And now our equivalent circuit is like this. This one is our RTH is 11 ohm. So this is 11 and our VTH is 12 ohm, so this is 12V. Now our formula to find the current flowing from this 5 ohm voltage is VTH upon RL plus RTH. This is the value of I. Okay. Now what we have to do to find this? We have to add our load resistance here. Okay, so we know that this is 8 ohm. So sorry, it was not 8 ohm, it was 5 ohm. Sorry, it's my mistake. Now the final answer that how much current is flowing from 5 ohm, this will be I equals to, you can say VTH is 12, RL is 5 and RTH is 11. That much ampere. This means 12 upon 16 ampere, that means 0.75 ampere. This is a way how we can solve the how much current is flowing from a resistance given in question. This is the way to solve using Thevenin's theorem. In the next video, I will show you how to do these problems using Norton's theorem. Thanks for this video.